Hello everyone and welcome to the channel. In this video I will be talking about Michaelis Menten equation, and this Michaelis Menten equation is itself incomplete without steady state approximation, so I will be giving a very brief introduction for this also, steady state approximation. And I have taken this topic because some of you have asked me to make video on this, and also I have seen that in previous 2-3 CSIR examination, like a question from 4 marks is fixed from this topic. They have been continuously asking question from this topic, and a question consists of 4 marks, and that include little knowledge of Michaelis Menten equation and steady state approximation. And that question, like, if you understand this topic easily, if you understand this topic well, then that question is not that difficult to attempt. Okay, so I will be making the understanding of this topic easier so that you can attempt that question, and at the end of the video I will be solving the questions also. So let's start with the topic. So this both of the things comes under enzyme kinetics. Okay, enzyme kinetics or enzyme catalysis. So under this topic you will find all these two topics, and the book I will prefer you to follow for this topic is Puri Sharma Pathania. Okay, so this book is very nice. It is very simple language also. They have explained in very simple language, so I will refer you this book to follow for this topic. Okay, I'll be giving you a very brief introduction, and if you want to understand in more detail, you can follow this book. So as you people know that what enzyme is, enzyme are the thing which makes reaction go faster. Okay, the reactions which are usually occurring inside a body, inside inside living organism, enzyme make it faster. So what enzyme does is, enzyme combines with a substrate, okay, and it gives a complex, enzyme substrate complex, which then forms product. Okay, so all these reactions are reversible. Okay, so this reaction is reversible, and this also is reversible, but the rate of reverse reaction is so less that it is considered to be one unidirectional only, that can be neglected. Okay, the reaction, because product will not convert into reactant, but the rate is very less. Okay, the rate is so less that it is considered as a unidirectional only. So this the rate constant for this is given as k1. For this, for reverse reaction, we are writing it at k minus 1, and for this we are writing it as k2. Okay, also one more thing which you should know, that if we keep the concentration of enzyme constant, and we keep on, like, if we keep on increasing the substrate concentration, keeping the enzyme concentration constant, then at very high concentration of substrate we will get a maximum rate. Okay, we will get a, if we draw a graph between substrate concentration and rate, then if you will keep on increasing this substrate concentration, then you will get at very high concentration, the substrate concentration is very high, but the rate will become constant and maximum rate. That maximum rate is called Vmax. Okay, so we will talk about this Vmax and all afterwards. Okay, so this is the basic thing which you should know. Okay, now the steady state approximation or the steady state assumption says that the concentration of the intermediate, that is this complex, is constant. Okay, the concentration of this constant is, this complex is constant. This is from steady state approximation or a steady state assumption. Okay, that means that formation of ES will be equal to loss of ES. Okay, how much it will be formed, that much it will be lost. So now if you'll write the rate equation, if you'll write it in the form of rate equation, then what we will get, the formation of ES we will get from K1 E into S. I hope you people are familiar with writing the rate equations. Okay, so I'm not discussing that over here. Is equals to the loss of this one we are losing this ES in the form of K minus 1 reaction, and another when it is converted into product. So we will write both of them. So one will be K minus 1 into ES plus K2 into ES. Okay, so like this comes from the steady state approximation. Now we also know that if there is total enzyme concentration ET, then this total enzyme concentration is only converted into the enzyme which is reacting and plus the enzyme which is forming the enzyme substrate concentration. Now here the thing which you should know is that this E is free enzyme, okay, free enzyme, and this is the enzyme which is bound to substrate, okay, which is bound to substrate to form the complex, and this is total enzyme concentration, total enzyme. Okay, so this equation says that the total enzyme will be sum of the free enzyme that is not bounded and the enzyme which is bounded to the substrate. So this is the equation we can write it as equation number 1. Okay, now if we will find out the value of E from here, so the value of E you will get as E is equals to ET minus ES. Okay, now let's put this value in this equation. Okay, so what you will get, you will get K1 ET minus ES into S is equals to K minus 1 into ES plus K2 into ES. Okay, so just simple mathematics, we have just put the value of E over there. Now just multiply and open the bracket from here. So what you will get, you will get K1 ET into S minus K1 ES into S is equals to K minus 1, sorry, K minus 1 ES plus K2 into ES. Okay, now what you can do, you can take this ES common from right hand side and you will get K minus 1 plus K2 over here, and here just write K1 into ET into S like the way it is written, K1, sorry, yeah, K1 ES into S. Now just divide the whole equation by this value K1. Okay, what we need to find out, we need to find out the value of, we need to just get ES one side. Okay, that's the only motive of it, of doing all these things. So we'll divide all the equation by K1, so we'll get ET into S minus ES into S, that will be equals to ES, and K minus 1 plus K2 upon K1. Okay, so this term which we have got here, we are just naming it as Km. This is called Michaelis Menten constant. Okay, I'm just denoting it by Km and I'll talk about it later. Okay, so for the sake of derivation, I'll just making it as Km. So the equation will become, sorry, it will become ET into S minus ES into S is equals to ES Km. Now as I have told you that ES should be on the same side, so we'll take it at that side, so it will become ET into S is equals to ES, just take ES common from here, so it will become Km plus S. Okay, or you can write that ES is equals to, sorry, ET into S upon Km plus S. So this you have got the value of ES. Now why we have find out the value of ES? Because we need to find out the rate of reaction. Okay, and the rate of reaction, that is the rate of formation of product, will depend on, see, dP by dt, the rate of product will be equal to how much the this complex is. If this complex will be more, the product will be more. Okay, it means it depends on the concentration of this complex. So that's why we have find out the value of concentration of this complex. Okay, so this will become dP by dt is equals to K2 into concentration of complex. So we'll just put the value of ES over here to get the rate of reaction, and the rate of reaction is denoted by V naught. Okay, V naught is the way of denoting the rate of reaction for this equation. Now, as I explained you, the rate of reaction V naught is equals to dP by dt, that is the rate of formation of product. P is denoting the concentration of product, and that will be equal to K2 into concentration of ES. Now we will put the value of ES from our previous equation, and that will make you to this K2 ET into ES, oh sorry, K2 ET into, that was only S, okay, and in denominator we were having Km plus S. So this is the equation for the rate of reaction. This is the Michaelis Menten equation for rate of reaction. Okay. Now there are certain conditions in which this equation, like this is the derivation, and this derivation you should know, because when the question will be asked, you should proceed it through the derivation only. So then only you will end up getting correct answer. Okay. So see, this is the last equation which you will get, but there are certain conditions also which you have to find out. What was Km? Okay, so what Km was, we will try to find out the definition of Km. Okay, so for Km, okay, Km was the Michaelis Menten equation. So if V naught means the rate of reaction is equals to V max, if it will be V max, then ET is equals to ES, because I told you that when the concentration of substrate will be very high, the rate will become Vmax. Okay, I told you in the starting only. So if the concentration of reactant substrate is very high, then the overall the enzyme which will be present in the reaction, that will be converted into enzyme substrate complex. So that's why the overall concentration of the total enzyme concentration will be equal to enzyme substrate concentration, and no free enzyme will be left, means no free enzyme will be left. That's why this is written over it. Okay, and like we can also write that it will be equal to K2 into ET. Why? Because as you can see here that V naught is equals to K2 into ES. So K2 is like that only, V naught is like that only, and ES is equals to ET. So that's why I have written ET over here. Okay, so this will be equal to V max. I have just put the values here. V naught is equals to V max and ES is equals to ET. That's it. Okay, so now let's put these value into Michaelis Menten equation. So what we will get? We will get V naught is equals to, now K2 into ET will become V max. S will be like that only, and here we will be having Km plus S. Now this you have got the final Michaelis Menten equation. Okay, so if derivation would be asked, you have to derive till here. What it means, what is the meaning of this? Okay, we will try to understand what is the meaning of this. Okay, what is the meaning of this? What is the significance of this? So if let's say Km is equals to S, if Km is equals to S, if both things are equal, then V naught is equals to V max S upon 2S, because Km will be equal to S, concentration of substrate. Now this will be cancelled out. That means that V naught is equals to V max by 2. That means if the rate of reaction is half of the maximum rate, okay, so let's draw it again, which I have drawn in the starting. So if it is the V max, okay, and if it is half of it, okay, if it is V max by 2, then at this time, at this value, the substrate concentration will be equal to Km. So this is the significance and this is the value of Km. So what this tells, that Km is equals to the substrate concentration at which the rate of reaction is half of the maximum value. So up till it was Michaelis Menten equation and the significance of it. Now let's try to solve the questions which are asked from here. Okay, so here I have taken a problem from CSIR December 2016 exam, and this question came for 4 marks. And the question says that the reaction goes through the following elementary steps. The two steps are given over here, and it is given that assuming that the steady state approximation can be applied to C, on doubling the concentration of A, the rate of production of D will increase by, and this is given something that assume that K2A is very less than K minus 1C, okay, and 4 options are given. So in order to proceed to this question, few things which you should know, that what are these fast and slow. Okay, so whenever something is like this fast and slow, then the rate of reaction will depend on slowest step. Okay, this you must have heard, and like till now you must have heard somewhere that the rate determining step is the slowest step. Okay, so the rate of the reaction will be equal to the slowest step, that is K2 into A into C. So this is the rate equation for this reaction. Okay, one more thing, that this they have asked the rate of production of the D, that means rate of production of product, that means the rate of reaction. Okay, and what is happening in the first step, in the fast step, it is a equilibrium step, and there what is happening is, since it is given that steady state approximation can be applied to C, and it is given like, it means that for C, rate of formation, okay, will be equal to rate of loss. Okay, that comes from the steady state approximation. So how C is getting formed? It is getting formed by C. To form C, we have K1 into A into B. Okay, so this is when C is getting formed, and when C is getting lost, we are having K minus 1 into C square. That means that what is the value of C square? We have to find out. The value of C square will be K1 upon K minus 1 into A into B. And in order to find out the value of C, why we are finding out the value of C? Because it is given that a steady state approximation can be applied only on C. And one more thing, that to find out the rate, we need to find out the concentration of C. So that can be found out from steady state approximation. So that's why we are applying all these things. So C will be equal to, we are naming it as a new constant K. So K to the power 1 by 2, A to the power 1 by 2, and B to the power 1 by 2. Now let's put all these values over here. So the rate will become K2 into A into K to the power 1 by 2 into A to the power 1 by 2 into B to the power 1 by 2. Let's solve it. So rate will become K2 into K to the power 1 by 2. These both are constant, so we are writing it in the front. Now A to the power 1 plus 1 by 2, that will become 3 by 2, and B to the power 1 by 2. So this is the rate reaction, rate, or like rate equation. Now from here you have to find out that it is given, on doubling the concentration of A, the rate of production of D will increase by how much amount. So we want to double the concentration of A. So let it be rate 1. Okay, so R1, let if concentration of A is equals to X, let's say X, and other things we don't have to take it, because both all the things are same, only we are changing the concentration of A. Let's take them also. So what will happen? K2 into K to the power 1 by 2, this will become X to the power 3 by 2 and B to the power 1 by 2. Now if A is equals to 2X, then you will get? R2 is equals to K2. I'm just writing R1 and R2 to denote, okay, when the concentration is doubled. K to the power 1 by 2, 2X to the power 3 by 2 and B to the power 1 by 2. Just divide both of these equations and you will get that R1 upon R2. All the other things will be cancelled out, only 1 upon 2 to the power 3 by 2 will be left. X will be also cancelled out. So what you will get, that R2 is equals to R1 into 2 to the power 3 by 2, or R1 into 2 root 2. So in this way this question is to be solved, and the correct option for this question was option number 4, that is 2 root 2 times. That means the rate of the reaction when we double the concentration of A will be 2 root 2 times of the rate of reaction when the concentration was not doubled. Okay, let's take few more questions. Okay, so now let's take this question which was asked in CSIR June 2017 exam and for 4 marks. And you believe it or not, this was super easy question, very easy. I can't believe that this was asked for 4 marks. Like, it was very simple question. Okay, just the thing you have to know is this Michaelis Menten kinetics or Michaelis Menten equation, and one more thing, that is turnover number. I will tell you what it is. So the question says that in the enzyme catalyzed reaction, the reaction is given which is the authentic reaction for that Michaelis Menten reaction. Okay, and the value of K2 is given here, and if E naught is nothing but this ET. Okay, so total enzyme concentration is given. Okay, so ET is only your E naught. Okay, so both are same only, so don't worry about that. It is given the magnitude of maximum velocity. You have to find out maximum velocity, that is V max, and turnover number. Okay, so turnover number and V max you have to find out. So turnover number or turnover number, okay, for Michaelis Menten equation, or it is also called as K catalyst, is equals to V max divided by E naught. Okay, so this is turnover number. So if you find out V max, then you will be able to find out E naught. Now see, if you know the value, if you know the Michaelis Menten equation, if you know what it is, and if you know the conditions for that, then this question is like for only for 30 seconds you will be able to solve this question. See how. As I told you that the final Michaelis Menten equation was this. Okay, V is equals to V max substrate concentration upon Km plus substrate concentration, and this was the Michaelis Menten equation. The condition for this was that V max is equals to K2 into ET. Okay, so for this reaction, for this condition, we will be writing it as that V max is equals to K2 into, instead of ET we will be writing E naught, because I told you that both of them are same. Now both of the values are given in the question, just put those values. So it will be 3.42 into 10 to the power 4 into 1 into 10 to the power minus 2. That will give you how much? 3.42 into 10 to the power 2. So that will be the value of V max. Okay, so this is the value of V max. Now this value 10 to the power 2 is given only in option number first. Now let's check the other thing. So the turnover number, okay, so the turnover number will be given by V max by E naught. Just put the value of that. So V max is nothing but 3.42 into 10 to the power 2 upon E naught is 1 into 10 to the power minus 2. So the solution will give you 3.42 into 10 to the power 2 plus 2, that is 3.42 into 10 to the power 4. So option 1 will be the correct option, because here you are getting both of the things, maximum velocity and turnover number. See how simple this question was. Just by knowing Michaelis Menten equation and the condition for this, you will be able to solve this. If you don't remember the exact thing, then if you practice 2-3 times the derivation of that, you will be able to derive it yourself, and derivation also doesn't take much time. It will just take 2 to 3 minutes for you if you will practice the derivation 2-3 times. Okay, and then you will be able to solve it easily. Let's take few more questions. Okay, so let's talk about this question. This question came in CSIR December 2017 exam, and it again came for 4 marks. And in December 2017 there were 2 questions, one in 4 marks and one in 2 marks from this topic only, enzyme catalysis and steady state approximation, and this Michaelis Menten equation. So the question says that the slope and intercept obtained from 1 by rate against 1 by substrate concentration of an enzyme catalyzed reaction are 300 and 2 into 10 to the power 5, okay, respectively. The Michaelis Menten constant for the enzyme in this reaction is, you are having 4 different options. So this question I have already solved, and I have solved it like 2-3 months before only, when CSIR exam held. After that only I solved it. So I will be giving you the link for this question. I'll insist you to solve it by yourself. You don't have to do anything, just write the Michaelis Menten equation. Just write it in the form of this, that 1 by rate, and it comes out to be 1 by substrate concentration, and then the rest of the things you will yourself get. Okay, so the slope and all you will get from equating it against the equation of straight line, that is y is equals to mx plus c. On y axis you will be having 1 by rate, on x axis you will be having 1 by substrate concentration. Okay, so if you don't understand it and if you are not able to solve it, I'm giving you a link for that to go and watch there. Okay, we'll talk about the last question from this topic, which was asked in CSIR December 2017 only. Okay, so this question again came from this topic, that is steady state approximation, and it came for 2 marks in CSIR December 2017 exam. And this was very easy question. Okay, very simple and very easy question. Like, okay, I'll tell you how to solve it. The question says that for a sequence of consecutive reaction, A turns out to be I, and then I is converting into product. The rate of reaction is given as K1 and K2. The concentration of I would be by steady state approximation. First of all, you have to find out that on which thing you are applying steady state approximation. So the thing which is getting formed and then it is getting deformed means that it is getting lost, or the thing which is acting as a product and then acting as a reactant, that can only act as a on that only you can apply this steady state approximation. So we can apply steady state approximation on I only. So what steady state approximation says, that the rate of formation of I will be equal to rate of loss, okay, of I. So what is the rate of formation of I? Just from here if you will write the rate law equation, so it will become K1 into A, okay, and rate of loss will be equal to K2 into I. In rate equation we always write the reactant, never we never write the product. Like if you have a like if you have a reaction like this, A turns to product, then the rate will be given by like if the K1 is the rate constant, so the rate will be given by K1A. Okay, if you have this square like 2A, so then it will become square, 3A then cube. Okay, so like that the rate equation are to be written. So here there is no like coefficient, so we are just writing like that. So K1A into K2I. So what will be the concentration of I? See how simple this question is. K1 upon K2 into, just K2 is gone there and it comes into division, so you will get K1 upon K2 into, and that is the value of concentration of I, and this is in the option number 4. So like this you would have gone, you would have got 2 marks easily without doing anything, like just simple mathematics, just very simple thing. Okay, so that's all for this video. I have taken few questions and I tried it to solve them in the easiest way I could and to explain you in the easiest way I can. So if you want to ask anything related to this video, you can ask in the comment section. If you want to give any suggestions, then also you are most welcome. You can give it in the comment section. And if you haven't subscribed the channel yet, please, I request you subscribe this channel. There are more interesting stuffs coming on, and I will be making more videos related to the CSIR exam. I know the time is not that much, but I'll try to cover more and more important topics which are like more probable to be coming in the examination. Okay, so thank you for watching. Please subscribe the channel if you haven't subscribed it yet. Thank you.